In this video, I will going to discuss underlying principles and strategies in teaching mathematics. But before that, I will introduce the learning outcomes. At the end of the week, the pre-service teacher should be able to describe constructivism as a strategy works in the teaching of mathematics. Describe how teaching for understanding can be used in mathematics teaching. Describe how Dale's cone of experience is applicable in mathematics teaching and learning. And lastly, describe how other constructivism strategies can be improved teaching and enhance learning in mathematics. What is constructivism? A constructivism is a theory that learners can construct knowledge through their experiences such that knowledge can simply be transferred from the teacher to students. Simply, when we say constructivism, students construct their knowledge for themselves. The main theories are John Dewey, Jerome Bruner, Piaget, and Vygotsky. John Dewey is also known for his theory wherein it is a learning by doing. He believed that constructivism can build individual social learning process. He is also a philosophical founder of this approach. Brunner, they are considered the chief theorists together with the Piaget among the cognitive constructivists. Brunner believed that the most effective way to develop a coding system is to discover it rather than being told by the teacher. Piaget's point of view to constructivism is the inspiration for radical constructivism due to his idea that the individual is at the center of the knowledge creation and acquisition process. Piaget, he is considered as the father of constructivism, while Lev Vygotsky, he is the major theorist among the social constructivists. But before that, what is social constructivism? Social constructivism, when we say social constructivism, it is a language and culture are the framework through which human experience, communicate, and understand reality. Now, we can proceed to constructivism in mathematics teaching. According to Elliott et al. 2000, constructivism is an approach to learning that holds people actively construct or make their own knowledge, and the reality is determined by the experience of the learner. So we have 5 core principles of constructivism. The first, knowledge is constructed. The second is active learning. The third is reality and mind. The fourth is social learning. And lastly, the knowledge is personal. At your screen, we can see the difference between traditional classroom versus constructivist classroom. The traditional classroom is a teacher-centered. It's specific to general. It's also strict adherence to fixed curriculum is high valued, wherein materials are primarily workbooks and textbooks. Learning is based on repetitions because in this traditional classroom, the learner are the passive or recipient only of the informations. So, assessment is through testing correct answers. Students work primarily alone, unlike in the constructivism, students primarily in group, and it is a student-centered wherein it's general to specific. It pursues of students' questions and interest is valued. Materials include primary sources of the materials and manipulative materials. Learning is interactive because it is student-centered, wherein students are able to actively engage in a discussions. So, students use inquiry and discover to learn. Teachers have dialogue with students, helping students to construct their own knowledge, and the assessment includes students' work observations and points of view as well as tests. Now we move on to the teaching for understanding mathematics teaching. In learner-centered classroom, teachers begin with the students' ideas. Students are allowed to solve problems or to approach tasks in ways that make sense to them. We have 3 parts of teaching for understanding for mathematics teaching. First, the teaching towards relational understanding. Second, teaching towards instrumental understanding. And lastly, teaching for understanding math curriculum. In teaching mathematics, we can use the cone of learning, the Dale's cone of experience. It is a model that incorporates several theories related to instructional design and learning processes, wherein there is a percentage that you can see on your screen that you remember. 10% of what you read, 20% of what you heard, 30% of what you see, 50% of what you see and heard, 70% of what you say and write, 90% of what you do. Simply, when we say Dale's cone of experience, it pertains to the actual performance of the students so that they can remember the percentage is higher when they are applying different theories or facts. So there are three ways of learning. Learning through abstractions or symbolic experience method, learning through observations or iconic experience method, and active learning, the synchronous learning or active method. As you can see on your screen, there are a lot of various constructivism strategies in teaching mathematics. There is some activities like experimentation, films, research project, field trips, class discussions, and campus quiz. These are the activities that can help students to improve, to gain or acquire knowledge with regards to teaching mathematics. So, in assessment, we have 2, 4, 5, the oral discussions, KWLH charge, mind mapping, hand-on activities, and pre-testings. So, sa oral discussions, the teacher presents with a focused questions and allows an open discussions on the topic. In KWLH charge, used throughout the course of the study for a particular topic, but it is also a good assessment technique as it houses the teacher the progress of the students throughout the course of study. While the mind mapping, students list and categorize the concepts and ideas relating to a topic. And when we talk about hands-on activities, students uses different manipulative tools, different concrete materials. So in pre-testings, it allows teacher to determine the pre-existing knowledge or what we call the schema of the students with regards to the topic. We have here the CRA or CPA model. What is CRA? It is concrete representational approach or the concrete pictorial approach model. Wherein we have first the concrete materials, then second the pictorial, and lastly the abstract. The concrete pictorial representational approach, it's a model wherein when we say concrete, teachers select manipulatives to demonstrate and allow students to explore a new concepts. In representational, often called the semi-concrete pictorial, this space transfers concrete model into visual representation using drawings and images. While in abstract, of course, it is a symbolic level. It uses operation like addition, subtraction, multiplication, and divisions, and mathematics symbols like greater than, is equal. That's the difference between the concrete, representational, and abstract, wherein it stated that in the discussion, if we're going to discuss the topic, we start first in the concrete, followed by the representational, and lastly, the abstract, so that students can easily understand the lesson. Another approach is the we can use mathematical modeling method. We have here a 5E lesson model. A mathematical modeling method is a teaching technique that focuses on the investigation of real-world problems using mathematics as a tool to make sense of the situation and map out the possible solutions. We have here a 5E lesson model: engage, explore, explain, elaborate, and evaluate. When we say engage, students are engaged with the challenging situations, prior knowledge is activated, and questions are provoked. When we say explore, students investigate the phenomenon, prior knowledge is challenged, and ideas are created. Explain, students explain the phenomenon, new knowledge is gained and applied. Elaborate, students apply their knowledge towards the new situation, and knowledge is deepened and extended. Lastly, when we say evaluate, students reflect on their knowledge and the learning processes assessment. In this video, you'll learn these underlying principles and strategies in teaching mathematics. Hopefully, those strategies, you can implement those when you are teaching mathematics, not only mathematics, and in all levels, if it is possible, to your learning outcomes. You can use those strategies so that students will learn from you. Students can easily understand your concepts or the topic that you will be going to discuss. And that's all for today's discussions. Hope you learned something new with regards to the underlying principles and strategies in teaching mathematics. Thank you.